Hello everyone. Today we are going to discuss the problem bit difference. So it is a difficulty easy question. So there are given two numbers A and B. Our task is to count the number of bits needed to be flipped to convert A to B. So notice flipping of bit means inverting its value, like changing 1 to 0 or 0 to 1. So the input sample 1 is A is equals to 10 and B is equals to 20. If you see in the explanation, A is equals to 0 1 0 1 0, B is equals to 1 0 1 0 0. So the first place 0 1 is not matching, so the count is equals to 1. And second place also not matching 1 0, so 2. So 0 1, it is also not matching at the third place, so 3. At the fourth place also it is not matching, so 4. Fifth place is matching. So total there are 4 places which are not matching with A and B. So the output is 4, like that. So same with the second example. We can see the expected complexity is log of max of A comma B. So we need to see the bits in the A and B which are not same at that bit position. So for this operation there is a best operation or operator called the XOR operator. So in which the result is 1 if the bits doesn't match, else 0 if so, like this. So XOR operator performs that if the result is 1 if the bits doesn't match at the particular position, and else 0 if the both bits match at the particular position. So we are going to use that and store in a variable. So declare a XOR variable and store the init. Declare a variable count to count number of ones in the output or the XOR output which we stored. So count the number of ones in the XOR output. We have a particular algorithm which is the Brain-Kernighan algorithm. So normally we can count like taking a string variable and continuously counting the 1 bits in its binary representation, but it takes the length of binary representation time complexity. But rather this takes the number of ones time complexity only, which is a slight optimization. So we use Brain-Kernighan algorithm. So in this we continuously perform AND operation on the current number and its and number minus 1. This gives a number whose rightmost set bit will be converted to 0. So until and unless we perform this until the number becomes 0, like all the set bits will be converted to 0 and our count will be equal to the output. So count value is the output like that. So if you see in the code, what is the first one? To declare a XOR variable, so int XOR is equals to a XOR operator is like this, cap symbol, and B, and count is equals to 0 to count. And after that we said we will use the brain algorithm, in which until the XOR is greater than 0 means all the set bits are not converted to 0. So we will continuously XOR is equals to XOR, and we wrote that XOR minus 1. So like that, count plus plus. At last return the count. So if you see, the sample test case is passed. The hidden test cases will be, you can see it is executing. So it is passed. So now we need to analyze the time and space complexity. It takes big O of 1 of space. It also takes big O of 1 of space. It takes set bits number of count. Let us assume like a log of A, comma B or anything. So inside also nothing is there. So finally time will be approx set bits of count space will be 1. So if we compare, the space is same and the time is like equal or less than, because if our time complexity is more than the specified one, then obviously the solution will not be acceptable. But it is submitted and all the hidden test cases are also passed. So our time complexity is either equal to this or less than this. I think maybe slightly less than this. So this is how do we solve this program using a simple technique, the XOR operation and the brain Kernighan algorithm. You can also do it using a small simple string and counting the 1 characters, but it is a more optimized, small optimization over it. So kindly go and practice this problem. Program link is given in the description. Thank you for watching. Subscribe to our channel.